Hello, welcome back to Solving Systems of Equations. In this video, we will use the method called elimination. The elimination method works best when both equations are in standard form. Ax plus by equals c. That means x and y are on the same side. And here are our steps. Number one, multiply if necessary to get one of the variables to have opposite coefficients. Step two, add the two equations together to eliminate one variable. Step 3, solve the resulting equation. Step 4, substitute the value found in step 3 into either of the original equations. Step 5, solve the remaining variable and write your answer as an ordered pair. So example 1. They are in standard form. X and y are on the same side. You might notice that in the first equation, y has a coefficient of 1, and in the second equation, it has a coefficient of -1. Therefore, we can add the equations together. 2x is equal to 8. Divide both sides by 2. X is equal to 4. Now we'll substitute x equals -4 into one of the original equations to solve for y. Doesn't matter which one you use. I'm going to use the second equation. So I have -4 minus y is equal to 0. Going to add y to both sides. So y is equal to -4. And then we'll write our answer as an ordered pair for -4. Example number 2. They are written in standard form, however, they do not have an opposite coefficient. So I would suggest we multiply one of the two equations by -1 and eliminate y. So I'm going to choose to multiply the first one by -1. It doesn't matter which one. And then I'll leave the second equation alone. I now have -y and a positive y, so the coefficients are opposite. So I will add the two equations together. -6x is equal to 12. Divide both sides by -6. X is equal to -2. Substitute -2 into one of the original equations for x. I will select the first one. 2 times -2 plus y equals -4. And y is equal to 0. Always write your answer as an ordered pair. Number 3. They are both written in standard form. However, we do not have opposite coefficients. So I'm going to multiply the second equation by -4 because that will give me a -8x. Again, this isn't the only way to solve this problem, but for me, it looks the easiest. So I'm going to multiply the second equation by -4. And the whole objective is to be able to add the two equations and eliminate a variable. So 8x plus -8x is 0. So I've eliminated x. 6y minus 16y is -10y. And 34 plus -64 is -30. Divide both sides by -10. And y is equal to 3. Now let's substitute in y equals to 3 to one of the equations. It doesn't matter. I'm going to choose the second one. and solve for x. Subtract 12 from both sides and divide both sides by 2. Write your answer as an ordered pair. Example 4. The objective is to be able to eliminate your variable. So one way is if we multiply the first equation by 3 and the second equation by 5. Why did I choose to do that? Because I will have a negative 15y and a positive 15y, so that when I add the two equations, I can eliminate y. So I have to take 3 times 5x and 3 times negative 5. And 3 times negative 10. And then in the second equation, I'm going to multiply each term by 5. And now I add the two equations. So 5x is equal to negative 5. Divide both sides by 5. X is equal to negative 1. And I'm going to substitute in negative 1 into the second equation. You can substitute it in either one. And we'll write our answer as an ordered pair. All right, number 5. If we multiply the first equation by 2, we will have opposite coefficients for y. So we have negative 2x plus 4y equals 8. And I'm going to leave this equation alone. You might notice something going on here. When we add the two equations, we have 0 is equal to 20. Again, on what planet is this true? It is not. This is false. The variable has been eliminated, and what is left is false. 0 does not equal 20. So we know that this system has no solution, which means the lines are parallel. Example 6, let's multiply the second equation by 3. And we'll leave the first equation alone. And now we'll add the two equations together. And we have 0 equals 0. True statement. The variable has been eliminated. And what is left is true. 0 is equal to 0. So this indicates that we have infinite many solutions. They are the same line. And we have one more problem on this worksheet. However, in the next video, we'll have a whole bunch of application problems. But we'll go ahead and get started with this one. A total of 10 rooms at a hotel are rented at rates of $110 per night and $150 per night. The total amount of money collected for the 10 rooms is $1,340. How many rooms were rented at each rate? Let X represent the number of rooms at $110, and Y represents the number of rooms at $150. So we can solve this using two equations and two unknowns. We know that there are a total of 10 rooms. So if we know that X is a number of rooms at 110, Y is a number of rooms at 150, we know that X plus Y has to equal 10 rooms. And then our second equation will be money. So we need 110 times X plus 150 times Y is going to equal the total amount, which is 1,340. And then I will leave this for you to solve.